I'm Chang.
I'm Kelsey. This is Lab 10 semiconductor light sources.
And our TA is Susanna.
So the purpose of this lab was to measure the physical characteristics of the LED and laser diode. We did this by using this microscope. So we measured how big the laser diode cavity is compared to the light emitted. Blue LED, green LED, and the red LED. Measure the number of pixels, converted that to microns.
Additionally, we compare the LED and laser diode output power. We mount the LED onto the integrating sphere. Now we change the current using this DC power supply. And here is a plot of the laser diode output power as a function of the drive current. As you can see, the power of the laser is now increasing significantly before it reaches the threshold, and then it will increase significantly with a linear fashion. And overall, the power output of LED is greater than laser diode. The purpose of this lab is to measure the divergence. We try to change the rotation angle, and then we measure the peak-to-peak voltage from the oscilloscope. In order to calculate the solid angle of the LED, we first calculate the area of this image, and then try to measure the distance from the source to the image. Here is how we do the calculation of the solid angles.
For the laser diode parallel to the junction, voltage has a sharp peak in the middle with not much width. It has a similar peak but much wider when it's perpendicular. LED, it was a much wider peak. The purpose of this lab was to determine the radiance of the LED and LD. Diode in line with a lens through the aperture, through the chopper, to another lens to the detector. The unmasked peak-to-peak voltage of the LD, then put in the mask and found the maximum peak-to-peak voltage, 66 and 142, magnitude smaller. LD, changing the polarizer, does change the voltage because it is coherent. LED does not change because it is incoherent.
Here is the grading spectrometer. See, there is a peak throughout the spectrum. In order to find the bandwidth, we can use the full width half max of the intensity. And here's the spectrum of the laser diode. We have the center wavelength. The width of the spectrum will be much narrower than the LED. Here is the wavelength of different colored LED.
When the current is too low, you can't see anything. Then as you approach the threshold, you get multiple modes. Then as it goes past the threshold, there's only one mode